Alrighty, welcome. We're going to go ahead and talk about solving quadratic equations using factoring. Um, so factoring involves breaking up a quadratic into two binomial factors, and then setting those equal to 0 to find our solution. So in this situation, right, we always set up an x. We're going to be looking only at quadratic equations that have a 1 here. If there is a number other than 1, this process gets a little more complicated. We have to introduce the factoring box, but for right now, we're going to just talk about them with a 1. So on the top of the box, you put in a times c. Again, since a is a 1, it's not very interesting. We're just going to be putting in the c value, the last number, the constant. And then on the bottom, we put the b value, right? This number here in the middle of our quadratic. And solving the x is about solving a kind of number puzzle for yourself. You're looking for two numbers that multiply to the top and add to the bottom. So let's go ahead and take a look at what that looks like for this particular problem. So I'm going to erase some of this. Alrighty. So for this problem, our c value is 34, right? 1 times 34, we're just going to get 34 here on top. And then our b value is 19, so we're going to get a 19 down here. So again, we're looking for two numbers that multiply to 34 and add to 19. Depending on this number up here, right, we can have a lot of options or a few of them because we always start with this number on top. How can we multiply and get 34? So you can do 1 times 34, 2 times 17. And that's it. Not a lot of options. So we need to figure out which of these factor pairs, if we add up the numbers, gives us the correct sum of 19. So if we go through this, right, 1 plus 34 is 35. So that's not correct. It's supposed to be adding to 19, so it's not that one. You may have already seen it, but then if we do 2 plus 17, we get 19. So that one is good, right? That's the factor pair that's going to work for this. 2 and 17, and both of those numbers are positive. So we can now take these solutions to our x problem, these numbers that solved it and gave us the answer to our x problem, and we can put those into our binomial factors, right? Because we had a positive 2, one of our factors is going to be x plus 2. And because we had positive 17, our other factor is going to be x plus 17. Great. Now we have what's called factored form. Once you're in factored form, the process is much simpler. We are going to make use of something called the zero product property. We have these two factors and they are multiplied to equal 0. So the only way this works and is true is if the factors themselves are equal to 0. So if this first factor equals 0, or if this second factor equals 0. Sometimes these equations are going to be very simple and you're going to be able to look at them and just sort of by inspection know the solution. Again, you might recognize that if I put in -2 right there, -2 plus 2 is 0. So that would be one of my solutions. If you don't notice that, it's fine. Solve it like a traditional equation, right? Get x all by itself. So we would take away 2, and this cancels. We get x equals -2. 0 minus 2 is -2. So that is one of our solutions. And then over here, again, you may notice the solution by inspection or not. You can try to solve it. Take away 17, and we get x equals -17. So again, just like using the quadratic formula or whatever method here, we should be getting two solutions to these. On a rare occasion, maybe we get the same solution twice, but we should always have two answers. Alrighty. This one was a little bit on the easy side because we were dealing with all positive numbers. We can kind of look at some other things that can happen. Alrighty. So here we have a new quadratic, and we're going to try to, again, factor that out into its binomial factors, and so I'm going to set up an x. We need two numbers that multiply to -30, that goes on the top of my x, and then add to 7, that goes on the bottom. So it's multiply on the top, that's our c, and then it's add on the bottom, and that again is our b. Now, Again, just like last time, we had a 1 here, and all of them we look at today will have 1s, so I don't need to multiply that. Technically, it's A times C, but multiplying by 1 doesn't do anything. All right. So we are figuring out two numbers that multiply to negative 30, so negative 30, and add to be 7. Okay, so negative numbers are a little tricky because they actually mean I have two different ways to get this. Because to multiply and get a negative number, I need one number that's negative and one number that's positive. So it could be negative 1 and 30, or it could be 1 and negative 30, right? So it's sort of doubling the number of things it could be when we introduce this negative number. Now, fortunately for us, I know that the larger number has to be the positive number, because when I'm adding them together, they need to be positive. So that's not actually going to work. So moving on, let's go ahead and go through the different lists of these. So you could do negative 2 times 15. That works. Negative 3 times 10 also works. And finally, negative 5 times 6. That is another way to do this. When I go through these and I try to figure out which one will correctly add to be 7, I find this answer right here. Because if I do negative 3 plus 10, I get 7. So that is the pair of numbers that we're going to use to solve this x problem. So we have negative 3 and positive 10. And we want to translate those now into what the binomial factors would be. So for a negative 3, that means one of my factors is going to be x minus 3. And because we have plus 10, our other factor is going to be x plus 10. I am allowed to take this particular shortcut where I can go from these solutions into the factored form, again, only when I have 1x squared. If I have a number in front of here, the process is slightly more complex than this. All right. So finishing and solving this, we again use our zero product property. We set up our two equations. And we solve those, right? So we're going to get a solution of x equals 3 and x equals negative 10. Again, you're maybe noticing, or maybe you already know, some shortcuts that are present here, right? My solution, 3, is the opposite of what I have here, right? The opposite of this, negative 3. X is 3. My solution here, negative 10, is the opposite of what I have here, positive 10, right? So there are a lot of other shortcuts that can be taken to come up with these solutions a little faster. All right. Moving on, we're going to take a look at another one just to see some variation here. So here we have x squared minus 14x plus 40. So when we set up our x, that's going to go on the top, 40, and negative 14. That's going to go on the bottom. So we're looking for two numbers that multiply to 40 and add to negative 14. So 40, listing my factors out, 1 times 40, 2 times 20, 3, no, 4 times 10, and 5 times 8. I believe that's all. But I'm noticing a problem. When I go to add all these numbers up, since everything here is positive, how am I going to get a negative 14? Turns out there's another way to multiply and get a positive number like this, right? If both numbers are negative, I will also get a positive. So let's just make both of the numbers negative in these pairs. And now when I add them together, I might notice that this answer right down here is the one that works. If I do negative 4 plus negative 10, I get negative 14, right? So that is the one that works here. So if I'm multiplying to get a positive number, but they're adding to be negative, I need two negative numbers. Alrighty, so let's write out that factored form from this. That's going to be, it's negative 4 and negative 10, so that means it is x minus 4 and x minus 10. And once again, you probably, with these simple of equations, can look at these and sort of by inspection find the solution, right? 4 minus 4 is 0, so we're going to get x equals 4. 10 minus 10 is 0, so we get x equals 10. Again, also, it's the opposite of these. Instead of negative 4, we got a solution of positive 4. Instead of negative 10, we got a solution of positive 10. Or it's the opposite of the factor. Instead of minus 4, we have a positive 4. Instead of minus 10, we have a positive 10. Again, there's a lot of places that we can take these shortcuts. But if you're not comfortable with those, you can always set up the equation, right? And solve those. Now, careful. if we start with a problem that is already in factored form, we need to be careful here, right? Let's say we have one that's already factored, like this. Now, if we go to think about our shortcut and we say, oh yeah, the solution here, this is going to be x equals 7, right? Positive 7. That is not true, because if I plug that in, 2 times 7 minus 7, that's 14 minus 7, that's 7. It's not 0, doesn't work. So you got to be careful. If there is a coefficient, a number in front of our x, you really do need to set up and solve that equation. So what does that look like? Right? You take this, you set up the equation, 2x minus 7 equals 0. And you solve this. So we add 7 to get rid of that. 2x equals 7, and then we divide by the coefficient in front of x, so divide by 2. Divide by 2. That's going to give us x equals, and now we have a bit of a choice. You could leave this as a fraction, you could get a decimal, you could put it as a mixed number or whatever. I'm going to leave it as a fraction, 7 over 2. Now, that's different than this one. This one doesn't have that coefficient, so we can actually just take our shortcut here. We're going to get a solution of negative 11. So again, coefficients in front of x, which you may not have to do that when you're factoring, but you may be given an equation that starts out that way. You really do need to solve the equation. All right.